Welcome back. Today, guys, we are going to build on what we started last class on writing chemical equations, writing chemical formulas, and balancing them. But today, we're going to take it a step forward. Last time, we gave you the reactants and the products. Now, today, at the end of this, you're going to be able to get the start with the reactants and figure out what products are going to be formed based on the type of chemical reaction. Well, how do we know what type of chemical reaction? We look at what we're starting with. So make sure you're paying close attention today. Take notes. Make sure you get all this down. If you have any questions, as always, please come and see me. There are 5 basic types of chemical reactions that we're going to worry about for this class, and they are direct or combination reaction, combustion reactions, which are simply a variation of the first one, what we call decomposition reactions, single replacement reactions, and then finally double replacement reactions. You're going to be held responsible for identifying each one of these and being able to write the products based on the reactants. So pay close attention today. Okay, our first type is direct combination reaction. In a direct combination reaction, 2 or more reactants come together to form a single product, meaning one element plus another element gives us one compound. Okay. These are also going to be referred to as either a synthesis or a composition reaction. You'll hear me use all 3 of these in class, so be familiar with each of those. And for each of these reaction types, I'm going to give you a generic formula. So the one for direct combination is this: A plus B gives us AB. And make sure you copy it down. An example of this would be sodium plus chlorine to give sodium chloride. Now, what I would give you is I'd give you AB, and then you'd have to figure out the final product here. Well, how do I know it's NaCl and not N2Cl3? Well, that goes back to what we learned in our bonding. We know this is a metal plus a nonmetal, plus 1 charge minus 1 charge crisscross, and you get NaCl. The 2 balances out our chemical reaction. So a direct combination, A plus B to give us AB. Okay, a couple more reactions. First one is a source of pollution. It comes from power plants that burn coal for their fuel. They produce sulfur in the air, combines with oxygen to give us sulfur dioxide. Sulfur dioxide then later combines with water to give us H2SO4, sulfuric acid, which then leads to acid rain. Second one here, look at this. Iron plus oxygen to give us iron 3 oxide. Anybody familiar with that? This is what happens when metal rusts. Okay, out here in Colorado, we don't have to worry about our cars doing it too much, but where I grew up back in Ohio, we used to have to worry about our cars rusting a lot. So that's kind of an important equation there. Now, a variation of the direct combination or the synthesis reaction is a combustion reaction. Okay, they're similar to the direct combination, but what we're going to see is we get more than one product form. The only combustion that we're going to worry about is the combustion of alkanes. Okay, we talked about those. Remember, alkanes are an organic compound. They're a hydrocarbon made up of only carbon and hydrogen. And what we see when they combust, meaning they combine with oxygen, they're going to produce carbon dioxide and water. Okay, so we start with a carbon-hydrogen compound. They combine with oxygen and give us carbon dioxide and water. Remember, our chemical formula for our alkanes is CnH2n plus 2. Remember those? Methane, ethane, butane, propane, pentane, all those. Yep, they're coming back to haunt you. That's why we told you to don't forget them. So our generic formula is this. Our alkane plus oxygen gives us carbon dioxide and water. Now, there are more combustion reactions. This is the only one that we are going to worry about. So make sure you know this equation. Our next type is decomposition. Think what it means for something to decompose. It breaks down, right? Well, in a decomposition, one reactant is breaking down into 2 simpler products. It's basically the opposite of our synthesis, our direct combination. So our generic form is AB breaking down into AB. So the opposite of that combination. Examples: water breaking down into hydrogen gas and oxygen. We can run a little electricity through water and get this to break down. Another example would be mercury 2 oxide breaking down into mercury and oxygen. Okay, so a couple of reactions there. You start with one compound, it breaks down into 2 simpler products. There are 6 basic types of decomposition reactions. You're going to be held responsible for memorizing 4 of them. Okay, so make sure you get these down. The first one is what we call a binary compound. That's what we just talked about, one product breaking down into 2. The next 3 are a little more specialized. First one is a metal carbonate. Okay, Sodium carbonate breaking down into a metal oxide and carbon dioxide. So sodium carbonate breaking down to sodium oxide and carbon dioxide. Next one is a metal hydroxide breaking down to metal oxide and water. So sodium hydroxide breaking down to sodium oxide and water. Example. Metal chlorate breaking down into metal chloride and oxygen. So sodium chloride breaking down to sodium chloride and oxygen. It is really important that you know these. You need to memorize these. Okay, they're very specific. So pause this, make sure you get these down, then go to the next slide, and we will give you some more examples of each of these. All right, so binary compound. We already talked about this one. Water breaking down into hydrogen gas and oxygen. Electricity makes that happen. A metal carbonate, we can take calcium carbonate, remember CO3 is our carbonate, breaking down into calcium oxide and carbon dioxide. Okay, metal hydroxide, barium hydroxide breaking down into a metal oxide, barium oxide, plus water. And then our third type is metal chloride. So aluminum chlorate, break it down to aluminum chloride plus oxygen. It's going to be really important for you guys to memorize these and realize what each of these is, how they break down. If you ask me in class, I'll show you how I remember these. It's a little tricky, so I don't want to go it on the video. So ask me in class and we'll go over this. Okay, our next type is a single replacement reaction. Okay, what happens in a single replacement is that an uncombined element, meaning an element just hanging out by itself, replaces another element in a compound. So our generic formula is something like this. A plus Bx gives AX plus B. You can see A replace this A, kick B out, and replace it there. Okay, examples. Iron plus copper sulfate gives us iron 2 sulfate plus copper. The iron kicked the copper out. Another one, chlorine plus potassium iodide gives us potassium chloride plus iodine. Now notice in this first one, it was the metals that were changing, right? This metal replaced this one. And the second one, it was the non-metal replacing the non-metals. It can happen either way. So metals replace metals or hydrogen. Non-metals replace non-metals. Now, it's not quite that simple. Okay, when a metal is going to replace a hydrogen and water, so something combines with hydrogen, you're going to get a metal hydroxide and hydrogen as your byproduct. So remember that. You'll see that a few times. Okay, but like I said, it's not quite as simple as it seems. Not all elements can replace each other. Picture this. You go to a dance on a blind date. You know, you get there, your date turns out to be a dud. They just want to sit at the table. They don't want to dance. You really want to get out there and dance. You want to replace your date, right? But you're not going to replace him with somebody, some guy sitting there or girl sitting at the other table who's not dancing, who's just being a lump on a log. You want to replace him with somebody that's more active, somebody that's out there that's dancing, having fun. Well, single replacements are the same way. Okay, so the tendency to replace an element depends on the activities of the elements involved. The one doing the replacing must be more active than the one that's already combined. So a more reactive element will replace a less reactive element. Okay, it doesn't happen the other way around. You're not going to dump your date for somebody more boring. No, you're going to dump them and find somebody more active. Okay, the way we tell this is what we call an activity series. Don't copy this. I will give this to you in class. But the activity series tells us if these reactions are going to occur or not. Okay, so it predicts that the single replacement will occur. Let's say you're iron. Okay, and you're on a date with lead. Lead's just being boring, not doing anything, and you see you want to replace him. Well, you're going to replace him with somebody that's more active. Okay, so maybe zinc, carbon, aluminum, one of these guys. They're more active. You're not going to go down lower to copper, gold, and silver. They may look flashy, but you know, no, they're boring. They're just sitting there. So in order to do the replacement, you must have somebody more reactive or more active on there. Yes, ask me about this in class. I have a whole story, dating scenario for all these. You'll love it. Ask me about it. Okay, so that's single replacement. A single element replacing another element in a compound. It's only going to replace it if it's more active. Okay, now this is kind of an activity series for metals. For nonmetals, we just use group 7 and go down to that. So our that group 7, look at that, and that's our activity series. Our final type is a double replacement reaction. Double replacement reaction involves ions in two different compounds replacing each other. Metals replacing metals, nonmetals replacing nonmetals. Okay, so the generic form is AX plus BY, and gives us AY plus BX. It's kind of like you go on a double date, and you both decide you don't like your dates, so you swap dates. There we go. That's a double replacement. Okay, examples. Silver nitrate combined with sodium chloride gives us silver chloride and sodium nitrate. So the silver went with the chloride, the sodium went with the nitrate. Another example, lead 2 nitrate going with sodium sulfide gives us lead 2 sulfide and sodium nitrate. Okay, we're swapping dates basically. We're switching out. Okay. But not all compounds are going to replace. Okay, you can't automatically swap somebody's date. You got to find, there's got to be some reason to do it. Okay, and there are several determining factors whether compounds are going to be able to swap out. The first one we see is most double replacements will not occur unless they're in an aqueous solution. They have to be dissolved in some kind of water to make this happen, because we have to break them apart. And they're more likely to proceed or switch partners if we get the formation of a precipitate. Remember, precipitate is a solid that forms, so if we get at least one of the products is going to form a precipitate or a non-soluble gas, that reaction is going to occur. Well, how do we know this? We use what we call a solubility chart, which I will give you in class as well. And when we use a solubility chart, we're looking for a P or I. Let me just show you this quickly. Here's an example of a solubility chart. Let's say we're lead 2, okay? And we're going to swap out with, let's say, something that has an oxide and form a lead oxide. Well, if we go across this way till we find oxide up above, we find our letter P. That's going to form a precipitate. That works. Now, if we were going to form out with, say, lead nitrate, lead 2 nitrate here, here's lead 2 nitrates right here, we're an S. It's soluble. That's not going to form a precipitate. That reaction is likely not to occur, and we just write that it does not occur on a reaction. So we'll go over more how to use this, and I'll give you a copy of the solubility, so don't copy this down. Okay, let me end here by giving you a little cheat sheet on how to remember these reaction types, because you're going to be responsible for all of them. So by knowing what your reactants are, you're going to be able to predict it, your product. So if you start with 2 elements, you're going to have a combination, a synthesis reaction, composition, 2 elements coming together. If you start with 1 compound, it's going to break down, okay, decomposition. Okay, remember there's 4 types, and you got to know all 4 of those, so be aware of those. If you start with an element plus a compound, it's going to be a single replacement if this single element here is more active than the one in there. And finally, our double, so look at our activity series. Finally, if you have 2 compounds, you're going to have a double replacement, but one of them at least has to form a precipitate. Okay, so look at the solubility charts. Alright guys, thanks for hanging with me on this one. Very important that you learn these different reaction types. Okay, there's 5 different reactions, but one of them has multiple, so you need to get these down. Okay, no longer are we going to tell you what your reactants and your products are. We'll tell you what's reacting. It's up to you to figure out the products, correctly write those products, and then be able to balance out the equation. So we're going to spend a lot of time practicing this. Okay, but if you don't understand anything, get a head start on it. Come in and see me, or if you have any questions, write them down and make sure you ask in class. Okay guys, until next class, take care. We'll talk to you soon.